Hi, my name is Leonardo Frid and I'll be guiding you through this brief tutorial on loading spatial inputs into STSim. This tutorial follows on the tutorial called Spatially Explicit Events in STSim, and for this tutorial you should be using STSim version 3.0.36 or later. I'll give a very brief review of the previous tutorial materials and then guide you through loading spatially initial conditions and spatial probabilities into STSim. Now to begin the tutorial, you'll need to navigate to synchrosim.com, and on the menu on the left, click on the tutorial link. You can then scroll down to the Spatially Explicit Events tutorial, which was a tutorial just immediately before this one, and click on the link to download the materials generated in that tutorial. Once the file is downloaded, I'm going to show it in the folder, and I'm going to right-click on it and extract the contents of this file to my documents. While we wait for those contents to extract, I'll just give an overview of the materials that we covered in previous tutorial. Again, following on the figures shown in the paper entitled State and Transition Simulation Models, a framework for forecasting landscape change, which was recently published in Methods in Ecology and Evolution. Now, if I scroll down to figure 1, you'll see the model that we developed in the very first non-spatial tutorial, again representing a landscape with a simple model that differentiates the possible states that could occur at any one location in space. And those states consist of deciduous forest in yellow, mixed forest in brown, and coniferous forest in green. Now, this transition pathway diagram shown in the forest describes how a particular location in space can move from one of these states to another via different kinds of transitions. And in this case, they are succession in blue, fire in red, and timber harvest in purple. In the non-spatial tutorial, we showed how to create this model with probabilities and a non-spatial initialization of the landscape. And we were able to model how the distribution in states changes over time for this simple landscape. In the second tutorial, we actually modeled the same landscape spatially, and we're able to produce raster outputs showing the actual location of different states on the landscape, as are shown in this figure. And finally, in the third tutorial, I'm just going to scroll down, we added the modeling of events such that cells can interact with each other. And in that example, we used transition size distributions to define the size of events that we expect for fire. Now in this tutorial, I'm going to be showing you how to load spatial inputs into STSim. And there's two kinds of spatial inputs that I'm going to show you. The first is how to initialize the state of each cell in the landscape explicitly for a particular location, as opposed to just based on a distribution. And the second spatial input, which I'm going to show, is how to allow probabilities for a particular transition to be defined in space. And so in that example, we're going to be loading an actual map of where we expect fires to occur in the model for a particular point in time. Now, returning to the files that I just extracted to my document, there's actually 6 files contained in that zip that I just downloaded. The first is the STSim library generated in the previous tutorial, and actually it's accompanying folder. So there's a stsim.input and an stsim.output folder with the same name. And there are also 4 raster geotiffs, which I'll be showing you a little bit more closely, but these represent the spatial inputs that we're going to be loading into the model at runtime. So I'm now going to start STSim, and I'm doing so with a shortcut on my toolbar, but you can also access it through the Start button. And once STSim is loaded, I'm going to navigate to that STSim library that I just downloaded. So File, Open Library, and I'm going to point to My Documents and scroll down to this file. Now, because the library that I downloaded was actually created with a previous version of STSim, I'm being prompted to update to the current version, and I'm going to click Apply. And note that when libraries are upgraded, there is a backup created before the upgrade is completed. So now here's my library in the Library Explorer, and I can expand the node to show the one project contained within it called STSim Demonstration. I can expand that node and show the folders that we created in previous tutorials. So there's a non-spatial folder which contains 2 non-spatial simulation scenarios. And there's a spatial folder that creates the second tutorial, which ran the model spatially, but with each cell transitioning independently of other cells. And then the last tutorial scenario is the one which we generated with size distributions, in which we modeled fire events. And just as a reminder, I'll just review a little bit the material that is included in that scenario. So we ran the model for 10 time steps and 10 iterations. We included a transition pathway diagram that has different probabilities for the different kinds of transitions that can occur, including fire, succession, and timber harvest. We defined, in this instance, non-spatially, how the landscape is initialized by saying the landscape consists of 1,000 acres simulated with 1,000 simulation cells, each cell being 1 acre in size. And we define the initial proportion of the landscape in different state classes, coniferous, deciduous, and mixed, and age ranges. And you'll recall, because we don't provide a map, each cell is initialized randomly then based on these proportions as they are specified. We also included an annual target of 20 acres per year of timber harvest for this landscape. And we defined the frequency of the different kinds of outputs that we would like to see. So now what I'm going to do is I'm going to make a copy of this scenario. And I'm going to put it into the same folder. And I'm going to rename it by opening it and selecting harvest 20 acre per year. And rather than using a fire size distribution, we're going to have spatial initial conditions and fire probabilities. Okay. So I'm going to keep the same parameters for the run control, 10 time steps, 10 iterations. But this time, under transition pathways, because we're going to be defining fire probability spatially, I'm going to navigate in the lower tab to the tab that shows all probabilistic transitions. And by clicking on the transition type column, I'm going to sort by transition type. And for the 3 fire transitions, I'm just going to use a value of 1 for the probability. And that's because elsewhere we're actually going to load a raster with multipliers against probabilities. And if we're multiplying against 1, that raster is essentially specifying the probability of transitions for each cell. Under initial conditions, rather than using the total area and the non-spatial distribution, I'm going to clear these values. And I'm going to show you where to load the spatial initial conditions data. Now, relevant to this, I should show you the definitions for what is being loaded. So first of all, we're going to be loading vegetation type, which in this instance represents the entire forest or the primary stratum that is being used to model. And so if I go to the project definitions by clicking on the project definitions icon up here on the left, you'll see that this landscape has a single vegetation type called entire forest, and it has an ID specified as 1. So this value is important because the rasters that we're going to be loading are geotiff rasters with integer values for each cell, and the integer values must correspond to the ID for the variable or the state variable that's being initialized. And just to show you what the raster that I'm going to load looks like, I'm just going to move over here to R and load the raster library. Then I'm going to show you the stratum raster. And you'll see that this raster that I'm going to load, shown on the right, is a single raster, and every single cell that has a value specified has a value of 1 being specified. And that's because our particular landscape just has a single stratum and it has an ID value of 1. So I'm going to go ahead now and load that raster. And again, this was one of the rasters that was contained in the zip file that I downloaded, and it's called initialstratum.tif. I'm going to load that one. And you'll note that as I load that raster, one of the things that's going to happen is I'm going to get some information about the number of rows, the number of columns, the cell size. In this instance, it's an acre in size, and the number of cells being simulated. Now, returning to the project definitions, if I then go to the States tab and look at the state class node, you'll see that there's 3 possible state classes for these landscapes. This landscape, and they each have an ID value. So deciduous has an ID value of 1, mixed an ID value of 2, and coniferous an ID value of 3. So if I return to R, I can show you what that raster looks like. And this is the initial sclass.tif raster. And so you'll see we have a bunch of white cells with a value of 1 representing deciduous forest, yellow cells with a value of 2 representing coniferous forest, and green cells with a value of 3 representing, coniferous forest in green, mixed forest in yellow. So one of the things you'll note is that rather than having a very random pattern, we see some spatial aggregation of the different types of state classes that occur on this landscape. And so now returning to STSim, I'm going to load this initial state class. And that's the raster called initial sclass.tif. And finally, in R, I'll just show you the initial age, which has a similar pattern to the initial S-class. But here, the integer values range from 0 to 70. And that's because cell doesn't need to be predefined, so we can just specify integer values as the starting age for each simulation cell. And again, you'll see these 2 large patches of age 0 cells, and then a few very old or older cells at age 70, and then some intermediate age cells in between that range. So now I'm going to load the age raster. Initial age.tif, select open. Okay, so now I want to be able to specify how fire events will occur in a landscape. And you'll recall in the previous tutorial under transition spatial, transition size, we defined a size distribution where we specified the size frequency of fire events. And we said in this instance that we expected 10% of events to be less than 1 acre in size, 20% to be between 1 and 10 acres in size, 40% to be between 10 and 100 acres in size, and 30% to be between 100 and 1,000 acres in size. So rather than using this kind of event module to simulate fire, I'm going to remove these values. And I'm going to be using the transition spatial multipliers. And so here, what I'm going to do is I'm going to show the time step field by right-clicking on the table. And starting in time step 1, for the transition group fire, I'm going to be loading a raster called multiplier no fire. And I'll show you what that raster looks like. So this is a raster where every single cell is yellow and has a value of 0.0. We are essentially setting the fire probability for all cells on the landscape to 0 and telling the model we don't want any fire in any of the cells in this landscape for a specified time period. And that, if you recall, this is a 10 time step run. So we'll say that until time step 5, we want no fire for any of the cells. For time step 5, we're going to be loading a raster called multiplier fire, and I'll show you what that one looks like. So here's a raster where there are a large number of cells with a value of 0 in white, so a probability of 0, but a specified number of cells, we're actually setting the probability of fire to 1. So we're telling the model exactly where we want the fire to occur for that particular landscape. So this might be an example that could be useful if you're doing a retrospective analysis where you know the exact locations where fires have occurred. Or if you're doing a prospective analysis and you have a fire model telling you where you anticipate fires might occur, you could then bring these inputs externally from out of STSim into the model run. And so returning to STSim, I loaded that raster, and then finally, from time step 6 until the end of the model run, I'm going to tell the model that, again, I don't want any fire for any of the cells. So once this has been defined, I can now save my changes. I can close this scenario window and this project definitions window and right-click and run. And we see the progress of our simulation on the lower left. And just for comparison purposes, I'll load the scenario that was ran in the previous tutorial, pardon me. And so let's look first of all at a chart of model states and transitions. And so you'll see, first of all, that we're starting out with a different initial state distribution. And that was the state distribution that was loaded in the blue scenario from the raster, rather than being loaded from just an initial distribution where each cell is assigned randomly to a specified state class. The other thing we notice is that the amount of fire is very different. In the blue scenario that we just ran, we see no fire for every time step except time step 5, whereas in the red scenario, there's a more constant amount of fire over time. With less fire in our model for the first few time steps, we're able to better meet that harvest proportion that was anticipated at 20 acres per year, or 2% of the 1,000 acre landscape. But you'll note that after we have that very large fire event, we're not able to meet that harvest target. And we see that also with less fire, or sorry, pardon me, that's the red scenario. The blue scenario is actually experiences some difficulty, probably because the starting age or starting states in the landscape to meet that target. And again, after that one fire event, also experiences some difficulty in meeting that target harvest distribution. And then finally, you'll notice with the blue scenario, with less fire, we have more opportunity for succession events, because if you recall, succession depends on the age of a cell, and the age of a cell is being reset to 0 by fire events. So now let's look at some of the spatial outputs. So first of all, we can look at transitions over time. And here's a chart showing fire transitions for the two scenarios. So at the top is the scenario we just ran, and we see that for the first 4 time steps, there's no fire. Time step 5, there's the fire exactly at the location what was specified in that fire probability raster. And from that point forward, there's no more fire again in the model run, as opposed to the previous tutorial scenario, which is simulating stochastically, but with autocorrelation between cells, fire events. And finally, let's look at the consequent corresponding outcome in terms of state and age. So we'll open that map. Okay, and again at the top, the scenario we just ran, we're starting out with a less random distribution of states because we loaded it from a raster rather than the initial distribution of states and ages that was initiated in the previous tutorial. And we see a bit of a footprint of that initial state distribution being maintained over time until time step 5, where there's a change in the middle where that fire event occurs, and those cells get, again, transitioned back to a deciduous forest. And that kind of footprint remains over the duration of this very short 10 time step run. And finally, I'm just going to arrange all just to make the charts bigger and reorganize them. Let's look at the fire probability. And you see, so we get very different outcomes. This is the average annual transition probability over the 10 time steps and across the 10 Monte Carlo iterations. So you'll see that we had a single fire occur on a set number of cells. And so on average, over the 10 time steps, the probability of a fire occurring to those cells is essentially 10%, right? 1 year out of 10, those cells burned. Whereas in the previous scenario that we ran, where the fire occurs is less predictable because the model is still simulating those stochastically using events following a particular size distribution. And just again, as a reminder, if you have any questions about this tutorial or other STSim material, you can go to syncrosim.com, which provides documentation on using STSim and SyncroSim, or you could also come to our website at ApexRMS.com and go to the forum page where, if you're registered, you can pose questions about using STSim. Thanks for listening.